Hello everyone, welcome back to lesson 8. In this lesson we are going to complete domain and range. Previously we talked about some general functions, how to find their domain, how to find their range. Then that was the last example we solved. Now we have the fifth type of function, which is absolute value. Absolute value function has a V shape. The V shape either opens up or it opens down. The idea is quite close to quadratic. Quadratic is a U shape. Again, it opens up or opens down. Then for V shape, domain is all real numbers. It has no problem. It's not like fraction or square root. Then domain is all real numbers. Range is, we need to find the vertex of the V shape. From the vertex all the way to positive infinity, if the absolute value is positive, or if the absolute value is negative, it will be from vertex all the way down to negative infinity for the range. There is an example. Find domain and range of fx equal to negative absolute value 2x plus 8 minus 1. Now, because this function is not roots, it's not fraction, then directly the domain is all real numbers, or from negative infinity to infinity. To find range, we need to find the vertex. To find vertex of absolute value, we take what's inside the absolute value equal to 0. What's inside the absolute value is 2x plus 8. 2x plus 8 equal to 0. 8 goes to the other side, becomes negative 8. 2x equal to negative 8. Divide 2, x equal to negative 4. This x equal to negative 4, if we look at it, it's x. And we know range is related to y. Then how can I make this x y? By writing this back into the function. Then I will find the y of it. This negative 4 means the V shape is upside down because of this negative. This V shape is upside down. Then this point, the x value of it is negative 4. The y value, I need to find it by writing x in place of, by writing negative 4 in place of x. Here, if I write negative 4, f of negative 4 minus absolute value 2 times negative 4 plus 8. 2 times negative 4 is negative 8. Plus 8, that's 0. Absolute value of 0 with this negative is still 0. Minus 1 is negative 1. This means this y value is negative 1. It makes the range to be from negative 1 all the way down to negative infinity, because range is related to y. Then the way we write this, we need to write the smaller one on the left. Negative infinity is less than negative 1. So negative infinity goes to the left side. The bracket is always open for negative infinity, and negative 1 is in. Why negative 1 is in? Because at negative 1 there is graph. And the number that results to negative 1, this number has no problem. It is in the domain. Then the negative 1 is in. In other words, I can say there is a number, if I put it in f, the result will be negative 1. So it means I'm sure that negative 1 is in the range because it's in the results as well. Number 6 is constant function. Constant function is a function like fx equal to 3, y equal to negative 6. These are called constant function. Constant function has the domain all the real numbers, and range is only the number itself. Let's have an example. fx equal to 4. How is the graph of this? This is an xy axis. At 4, 1, 2, 3, 4, there is a straight line. This straight line is the line of y equal to 4. We said range is related to y equal to 4. Y has no any other choice. It's only 4. This means range is only 4. This is how we write, only 4, using set brackets. It's not an interval, just 4. And domain, if we look at this black horizontal line, it covers the entire x-axis. It means if I write any number here, f of 0 is a, f of 2 is a, here f of 10 is 4, f of negative 100 is 4. This means I can write any number in this function and I will never get something undefined like negative under radical or fraction over 0. Then domain is all real numbers, range is just 4. Piecewise function or conditional function. Piecewise function, the domain is already given. These are x less than negative 2, x less than equal to 2, x greater than 2. These are directly the domain. So domain is all the given intervals together. Okay. Range. To find range, we calculate the range of this one from 2 and less than 2. What are the numbers that we can have? And we calculate the range of this one. We will have a final answer. As calculation, it's a little bit complicated. So I suggest graphing piecewise functions. And usually, the pieces are simple functions that are easy to graph. It's easy to graph negative x plus 2. It's easy to graph square root x minus 2. Let's explain them. Domain is every number that is 2 or less than 2 in this side. In this side is every number that is more than 2. Numbers that are less than 2, numbers that are more than 2, and the 2 itself together, they cover the whole real numbers. This makes the domain to be all real numbers. Range. To find range, let's graph it first. To graph negative x plus 2, we studied how to graph in the first and the second lesson. Then negative x plus 2, you need to make an xy axis, xy. When x is 0, y is 2. X is 0, y is 2. When x is 1, negative 1 plus 2, y is 1. Then placing a straight line between the 2 points I plot. And I should stop at 2 in x-axis because of this. The 2 itself is in because of this equal. Then radical x minus 2. To graph this, we take what's under the root, x minus 2, equal to 0 to see where the graph starts. 2 goes to the other side, so x is equal to 2. This means this graph starts at 2, and graph of radical has a shape that looks like radical. Then starting from 2 to this direction, these x's are positive, and this x is positive. This is why it heads to this direction. If the x's were negative here, it would go this way. Now, if we look at this, it's clear that the domain is every x-axis, means all real numbers. The range, it starts from 0. For the range, we look at y-axis. On y-axis, the graph starts here, which is 0, and it goes all the way to positive infinity. Then range is 0, infinity. The 0 is in because we can see 0. When x is 2, negative 2 plus 2 is 0. 0 is visible. Then all the way to positive infinity. Infinity always has open brackets. Then for piecewise functions, it's better to graph than find the range. And most of the time, the pieces are simple functions that you can easily graph them. Number 8, trigonometric functions. This one needs a little bit of attention. Here, trigonometric functions are sine, cosine, and tan. Firstly, sine and cosine, they have no problem. Their graph is waves that covers all x-axis. This means Domain is all real numbers. Tan, in other words, tan is a fraction. It's sine over cosine. Each of sine and cosine are not fraction. Then their domain is all real numbers. Tan is fraction. Tan is sine over cosine. So the domain of tan is not all real numbers, while the range of tan is all real numbers. Let's see this. Range of sine and cosine. The graph of sine is waves from -1 to 1. Graph of sine, if this is -1, this is 1. Graph of sine is like waves. At 0 it is 0, goes up this way. And graph of sine is from -1 to 1. Similarly, graph of cosine is from -1 to 1. But if we have a number in front of the sine or cosine, like graph of 2 sine is from -2 until 2. On y-axis, we can find the range. Range of this graph is from -1 over to 1. If we have a sine bx, means a number multiplied by sine, then range will be negative positive of the number. Similarly for cosine, if we have, let's say, 5 cosine x, range is -5 until 5. A cosine x, range is from -a until a. Then there is a note. Tan is equal to sine over cosine. Tan x is sine x over cosine x. This means wherever cosine is equal to 0, tan has problem. Whatever number makes this x 0 is not in the domain of tan. We simplified this. Sine is always 0 at n pi, and n is an integer like -2, -1, 0, 1, 2. These numbers are called integers. Sine of any integer times pi is equal to 0. And when we are talking about sine cosine, consider pi as 180 in calculator. If the calculator is not on radian mode, then instead of each pi, you can write 180 in calculator. But for the calculations, we use pi. Sine is equal to 0 if the x is n pi. Cosine is equal to 0 if the x is n plus 1 over 2 pi. Means at the halves, cosine is equal to 0. Cosine is 0 for 1 over 2 pi. Cosine is 0 for 1.5 pi. Cosine is 0 for any number 0.5 pi, or any number plus 1 over 2, then all multiplied by pi. Cosine is 0. So since cosine is 0 at these numbers, n plus 1 over 2 pi, means tan has problem at these numbers. So domain of tan will be all real numbers except an x that is like n plus 1 over 2 pi. Then domain of tan is all real numbers except n plus 1 over 2 pi, and n is an integer like negative, 0, or positive without points, without fraction. There is an example. Find domain and range of y equal to 4 sine 3x. Let's do this. Y equal to 4 sine 3x. This 3x, this 3 is nothing. It will not change anything about domain and range. The 4 is important. Domain is all real numbers because sine, it's not fraction to be over 0. It's no root to have negative. Then domain is all real numbers. Range is, look at this number, 4. So range is from -4 until 4, both in. Find domain and range y equal to negative 5 cosine x. Range is from negative 5 until 5. Even if this number is negative, we don't care. We take the number once as it is, once multiplied by negative. So when we multiply this by negative, it becomes positive 5. So it doesn't matter if the number, the coefficient of the trigonometric is negative or positive. Look at the number, once negative, once positive, both in is the range. Domain is all real numbers because this is not fraction, this is not square root. There is an example. Find the domain and the range of each function. First one is radical x minus 1, secondly is tan. The first one is radical. To find domain of radical, we take what's under the root, greater than, equal to 0. Because the root is not under a fraction, it's just a square root, then what's under the square root? X minus 1, greater than, equal to 0. Okay, when we get negative 1 to the other side, x greater than, equal to 1. This is directly the domain. X greater than 1, we can write it as from 1 to infinity. The 1 is in because there is equal. Infinity is always open. This is the domain. The range, if you have a square root like this, it's 0 infinity. Whatever number I write here, the result is either 0 or positive. This is how we write 0 or positive, 0 or infinity. That was the range. If we look at the graph of radical x minus 1, x minus 1 equal to 0, x equal to 1. This means the graph starts at 1. Okay? The x is positive, goes this way. Domain is from 1 until infinity. Range is from 0. Look at y-axis. The graph starts here. Here, y is 0. And it goes all the way. As it goes beyond the graph, increases. The height increases. Then the y will be infinity. This range is from 0 to infinity. While we have the other one, part B, is tan. Firstly, tan is sine over cosine. Whatever value makes cosine 0, it means this value has problem with tan. Then what makes cosine 0? N plus 1 over 2 pi. It means domain of tan is all real numbers except an x value that is like n plus 1 over 2 pi, and n is integer. And it's explained here. Range of tan is all real numbers. Let's look at the graph. Graph of tan is like this. If we look at it vertically, it's covering all real numbers. It starts from negative infinity and goes up all the way to positive infinity. This vertical is range. So range of tan is all real numbers. Domain of tan is all real numbers except the numbers that make problem, that make the tan 0. This is pi over 2. This is negative pi over 2. This one is pi over 2. This one is pi over 2 plus pi, which means 1.5 pi. This one is pi over 2 plus 2 pi, which means 2.5 pi. Means any 0.5 with pi makes cosine 0. Like 0.5 pi, 1.5 pi, 2.5 pi, 3.5 pi, and so on. Same thing for the negative numbers. Then range of tan is all real numbers. Domain of tan is all real numbers except n plus 1 over 2 pi, and n is an integer. Two other examples and end the session. Find the domain and the range for each function. fx equal to 1 minus x squared, and that one fx equal to 1 over sine x. Okay, if there is a radical, I take what's under the radical, greater than, equal to 0, and solve it. Look at here. There is x power 2 under the radical, so there are two ways of doing this. One way is, if you remember, we studied this. This is a semicircle. A number minus x squared all under square root. This is a semicircle, center at 0, 0, radius 1. It's this. Center at 0, 0, radius 1. This means domain is from -1 until 1. Range is from 0 until 1. It's half a circle, then half a circle center at 0, 0. This is how it looks, from -1 until 1. Radius is 1, and the height is from 0 until 1. If you recognize it as a semicircle, it will be faster and easier to find domain and range. If you don't recognize it, then there is the other way that works pretty fine. Method 2. We usually take what's under the root, greater than equal to 0, and let's see. Here, what's under the root? 1 minus x squared, greater than equal to 0. Then, to solve this x squared is negative. Let's send this to the other side. So 1 is greater than equal to x squared. One greater than equal to x squared. Remember this. I need to remove this x squared in order to find x. To remove this power 2, I add square root for this, square root for this. When I add square root, remember to write plus minus on one of the sides. Doesn't matter which one. It's better to write the plus minus on the side that has the root. If I remove x power 2, it means I will have two possible answers. 1 or -1. Because 1 squared is equal to 1, -1 squared is also equal to 1. So when I remove power 2 on the x, I add plus minus. This means x, negative x less than 1 or x less than 1. X less than 1 is this, or negative x less than equal to 1. Multiply by negative, it will be -1. When we multiply any inequality by negative, we should flip the sign of the inequality. So we have x greater than -1 or x less than 1. If we pay attention to this, we have an x value that is more than -1 and less than 1. This means we have only from -1 until 1 on x-axis as domain. Then domain is from -1 until 1. Both have equal sign. This is why both brackets are closed. Domain is from -1 until 1. This way is an algebraic way through calculation. This one is recognizing that this is a semicircle. Semicircle has same radius in all the three directions. Here, to find range, okay, if I put 1, 1 minus 1 square is 0. If I put -1, again I get 0. Now I'm going to put the number that is exactly between 1 and -1. That's 0. Put 0 here. 1 minus 0, 1. Square root of 1, just 1. Means 1 is the highest possible number I can get. This means this is the highest value of range. And 0 is the lowest value of range. So range is from 0 until 1. You can rewind this part of the video to understand. Understanding this is really important. Why the range is from 0 until 1. If I put -1, I will get 0. If I put 1 here, I will get 0. Then I should put the number which is right between 1 and -1, which is 0. Then if I put 0, I will get 1. This means 1 is the highest value I can get for range, and 0 is the lowest. This is it. This is the end of this session. Thank you so much for watching. Stay tuned to see the rest of the book. Bye.
گروپی لاس بۆ فۆتۆکۆپی و پەراوگا لە خزمەتی قوتابیانی خۆشەویستدایە. بۆ ئەوەی لە وەرزی نوێی خوێندن ماندوو نەبن، ئێمە هەموو پێداویستەکانی قوتابخانەمان بۆ بەردەست کردوون بە بەرزترین کوالیتی و باشترین مەواد. لای ئێمە هەموو جۆرە مەلزەمەیەک بە کوالیتێکی بەرز و جوانترین شێواز دەست دەکەوێت. هەروەها هەموو پێداویستەکانی